Everyone, welcome back to Smiler Kids. Today we're going to see how to derive the Newton's second law of motion, that is F is equal to ma. So let's begin. F is equal to ma. We're going to derive this particular equation. Well, before we understand that this is the Newton's second law of motion, but what in fact it is. The rate of change of momentum of a body is directly proportional to the applied force. Wait, that's confusing. Let's consider an object of mass m with an initial velocity. Now, upon some force acting on this particular object, it undergoes some displacement and comes to a final position v in a certain amount of time interval. Now, what is the momentum in both the cases? What is momentum? Momentum is equal to mass into velocity. I hope you guys remember that. Now, the momentum in first case will be mu and the momentum in second case will be mv. Now, in Newton's second law of motion, Newton declared that force is directly proportional to the rate of change of momentum. So according to the Newton's second law of motion, of what we discussed earlier, the rate of change of momentum will be mv minus mu upon time taken, right? Which is directly proportional to the force. Now, F is directly proportional to the rate of change of momentum is what we discussed earlier. So this is nothing but force is directly proportional to rate of change in momentum upon time taken. Now, if you guys remember, the rate of change of velocity is acceleration. Yeah, we learned it in the first chapter, that is motion. Now, here look, F is directly proportional to, can we take m common out of it? Well, yeah. M into V minus U upon T. Now wait. V minus U upon T is nothing but acceleration. Let's substitute it. F is directly proportional to ma. Now wait, we need F is equal to ma. How do we do that? We're gonna take F is equal to K multiplied by M multiplied by A. Well, what is K here? K here is the constant. Hence, we arrived to F is equal to ma. Now, here K is constant. Now, what is constant actually? The SI unit of constant K is 1. And hence, we have arrived to the equation that is F is equal to ma. Now, let's understand this with a small example. Here we have a car. Well, yeah, you're traveling on it. This car weighs 600 kgs. Oh my god. And on the other hand, we have another car, which is super cool. Having a mass of 2000 kgs. Wait, what? 2000 kgs. Now wait. Since the acceleration produced is inversely proportional to the mass of the car, that is A is equal to 1 upon m, we can say that it is easy to move or it is easy to accelerate a car having less mass or the small car than a big car having a larger mass by the force of our push. This concludes that A is inversely proportional to the mass of the car, and hence we can easily accelerate a small car, but it's difficult to accelerate a big car. This is what we can conclude by the Newton's second law of motion. Thank you. And before leaving, do not forget to subscribe to our channel, Smiley Kids. Stay tuned for more.